Okay, so we've learned about ionic bonds and we've learned about covalent bonds. In this lesson, we're going to learn about sigma and pi bonds. You wonder, what on earth is that? We've figured out that atoms can gain or lose electrons to make ionic bonds. They can share electrons to make covalent bonds. Well, it turns out that sigma and pi are basically two varieties of covalent bonds. Our learning goals for this lesson are to recognize multiple bonds between atoms, and then understand the difference between sigma and pi bonds in molecules. And there are some important differences that will be consequential later in the course. I want to first consider the diatomic molecules that are formed by oxygen and nitrogen. You breathe these in every time you take a breath. If you didn't, you probably wouldn't live for very long. So let's see what the Lewis structures look like when we form these diatomic molecules. For oxygen, okay, the first two electrons that are shared by oxygen form a covalent bond, but that still leaves two unpaired electrons on either side of the oxygen. Well, those two can be shared between the oxygen atoms, and that leads to the situation where we form a double bond between the two oxygen atoms. When we look at nitrogen, form the first covalent bond, we still have two unpaired electrons on each of the nitrogens. Both of those can be donated in to form a triple bond in this case. And that, in fact, is one of the strongest bonds in nature. So both of these have formed something unusual, at least unusual to what we've seen before. These are multiple bonds that oxygen and nitrogen can form in their diatomic molecules. Do these satisfy the octet rule? Well, let's count them up. Let's look at the oxygen on the upper left. Okay, it's got two pairs of non-bonding electrons. Those represent 4 electrons. And each of the bonds in the double bond have 2 electrons, so that's 4 more electrons. That oxygen feels like it has all 8 of those, so yes, it does satisfy the octet rule. I think you can probably satisfy yourself that the same is going to be true in the nitrogen molecule, that both of the nitrogens have 8 electrons in their valence shell with 1 pair of non-bonding electrons and 3 pairs of shared electrons. Note that multiple bonds are going to be shorter and stronger than single covalent bonds. Okay, the more electrons you have shared in there, the tighter together it pulls those atoms, and it makes for a stronger bond. Now, as an activity, I'd like for you to consider this list of elements. These are from the periodic table and in the order that they appear in the periodic table, and figure out which ones of these can form a multiple bond. I'm going to give you a second to think about this. All right, if you've thought about it, maybe you've paused the video, which ones would it be? Well, you're looking for elements that have multiple pairs of multiple instances of unpaired electrons. Okay, hydrogen can't do it, bromine can't do it, fluorine and iodine can't do it, chlorine can't do it. They have only one unpaired electron, so they can only form one bond. But oxygen, nitrogen, and carbon, phosphorus and sulfur all have multiple instances of unpaired electrons, so because they have the possibility of making more than one bond, they can make a multiple bond. I should mention that although phosphorus and sulfur make multiple bonds, the strongest ones that we find in nature are typically the ones that are created by carbon, nitrogen, and oxygen. And we'll later on in the course we'll see some instance of this when we consider the energy of bonds. Now, a sigma bond is one in which the electrons are directly in between the two nuclei that form the bond. So a good example of this would be hydrogen again, where we brought two atoms together. This is a little cleaner cartoon of that bond, and you can see that they form a sort of coherent whole where there's electron density in between the two nuclei. That, by having it in there, it's holding those atoms together a little bit better, and that's really the lowest energy place where those electrons can go. So that is what we call a sigma bond. So you can think of it as being a very, like an ellipsoid or something, where the electrons are focused on the region in between the two nuclei. Should mention that all single bonds are sigma bonds. Okay, so you will always have a sigma bond if you have a single bond, and you will also have sigma bonds if you have multiple bonds, because one of the bonds in all multiple bonds is a sigma bond. The Y there is really what I answered before. The lowest energy place for the electrons to be is in between those two atoms, but once there's one sigma bond formed, there really isn't room for other electrons to go to that region. So now let's talk about pi bonds. A pi bond is one where the shared electrons are above and below the area where the two bonded atoms are. And they are formed when we take two parallel p orbitals and share them between atoms. So here we see two p orbitals. Remember, they had that characteristic shape like a dumbbell of an upper lobe and a lower lobe, and there's a place in between where you don't find electrons. When two of those come together, the sort of electron cloud they make in a molecule looks like the picture on the right, called the pi bond. So the electron density is above and below the nuclei. It's actually in both places at the same time, but it is not in the middle. So it doesn't get in the way of the electrons that are part of the sigma bond. Whenever you have a multiple bond, the first bond is a sigma bond, and the second and third bonds in a multiple bond is always pi bonds. So let's make this chart just to summarize what we know about multiple bonds. If it's a single bond, it has one bond, and that bond is a sigma bond. If we have a double bond, there are two bonds. One of them is a sigma bond, and one of them is a pi bond. If there's a triple bond, the first one is a single bond, and the other two are both pi bonds. So you can see that really what's happening here as we get to larger and larger bonds, multiple bonds, that what's added here are pi bonds going from 0 to 1 to 2. Be sure to watch the video as part of the Lesson 2B if you want an overview of this.